Welcome. In this video, I wanted to give an outline on how to solve problem 5. In problem 5, we have a train that moves at a constant rate of 60 kilometers an hour. However, it changes direction. So the trip of the train is split into 3 parts. The first part is where the train moves eastward, and that is captured by this black line. So it moves from some point called 0, which we will call our origin, to point A. And then when it gets to point A, which is after 40 minutes, it changes direction so that its new direction makes an angle of 50 degrees with the north direction or the y coordinate. That's because we were told that the direction it takes is 60 east of due north, and it undergoes this motion for 20 minutes. Again, maintaining the same rate of advance, which is 60 kilometers an hour for 20 minutes. And it goes during that leg of the trip, it goes from point A to point B. And when it gets to point B, it changes direction yet again. It heads westward at the same rate of advance of 60 kilometers an hour, but this time it travels for 50 minutes. We are then asked to find the magnitude and the angle of the train's average velocity during the trip. So, from definition, we know what the average velocity is defined as. It is the ratio of the displacement, that is delta r bar, divided by delta t. So this is our displacement. In other words, what's the difference between where we are relative to where we started? The train ends up here. It started there. So we want to figure out what is this change in position. So basically the final position minus the initial position. Based on this coordinate system, the train begins in the 0, 0 in the origin. So its initial position is going to be 0 I hat plus 0 j hat. So this part we already know. What we need to figure out then is what is its final position? How can we find its final position? Well, we need to realize that its final position is actually a composition of this motion first, plus that motion second, and then that motion. So how did the train get to point C? It first moved from point 0 to point A, and then from point A to point B, and then from point B to point C. That's how it landed up there. Now, we need to figure out in moving from point 0 to point A, how much distance did it cover? Well, the rate at which it's advancing here is 60 kilometers an hour, and the amount of time it travels that region is 40. And if we use our formula of speed being equal to the distance divided by time, we can determine that the distance is going to be the speed times the time. And over here, I'm just converting the units so that they're more meaningful. Because here, using seconds is going to be cumbersome. Of course, you're welcome to use any units of your choice, but here I have chosen to use kilometers and hours. So when we convert the units here, the minutes are going to cancel those minutes, the hours are going to cancel those hours. So, and the 60 is going to cancel that 60, we're going to be left with 40 kilometers. So the distance covered when the train moves from point 0 to point A, the distance is 40 kilometers. How can we write this distance here as a change in position? In other words, when the train is at point A, what is its position vector? Its position vector is going to be the y component, because here it's moving eastward. Its y component is going to be 0 when it gets here. But what will its x component be? Its x component is going to be this 40 I hat. So over here I have written that as the displacement, or rather the position vector when the train is at point A in unit vector notation. That's what I have there. And then I'm going to do the exact same thing for this part of the trip. I'm going to first find the length of this vector and then resolve this vector into components. The length of this vector, which is the distance between A and B, is going to be the speed the train is traveling at during that region times the amount of time it takes to travel that. So it's 60 times 20, and again I'm converting. I find that this is 20 kilometers. Now, this 20 kilometers is at an angle of either 50 or 40, depending on how you want to look at it. For my case, I have chosen to work with a 40, so I can write this vector, which is this magnitude and that angle. I can resolve it into components, and that's how I can write the position vector from A to B in unit vector notation. So this is what I have. And then finally, for the motion from B to C, we know that this is moving in the negative x, so which means its y component. In other words, the change in going from B to C, the position vector of the train would have a 0 y component, but it would have a non-zero, in particular a negative x component. So let's figure out what is this distance first. Again, it's the speed the train is traveling at here, and the time it takes to travel that region. So 60 is the speed, 50 is the time, and again converting, I end up with the distance between point B and C is 50 kilometers. Now let's write BC as a unit vector, or rather in unit vector notation. This is what we know. Because the train is headed westward, the x component is going to be negative, and it's not moving up or down along the y-axis, so its y component is going to be 0. So now we can easily figure out where is the train now located. In other words, what is the position vector that stretches from here to here, from O to C? This is the displacement. The train started here, now it's over there. So it's going to be this position here minus that position here. That will be our displacement. It's going to be final position minus initial position. But what is this final position? This final position is made up of OA plus AB plus BC. So we're going to add these vectors, vector OA and vector AB and vector BC. And if we do that, which is what I've done here, we're going to obtain something like this. And once we have delta R, we simply divide it by the total time. The total time it took the train to go from point A to point C, from point 0 to point C, is the amount of time, is the sum of the times in each part of the trip. So it's going to be 40 plus 20, which should be here. Actually, that's the 20, plus the 50, which should be there. And that's exactly what I got. And I've converted it now to hours, so it's 1.833 hours. So from here, I believe you should be able to find what the magnitude is. You should be able to find what the magnitude of the average velocity and the direction. Okay, I will stop the video here and see you in the next one.